So we have a graph that gives the velocity v of t of an object in feet per second as a function of time t given in seconds. And we're going to use the graph to answer the following questions. Now remember, when our velocity is negative, we can think about it as moving backwards. When our velocity is positive, we can think about it moving forwards. So we want the total distance traveled by the object in the first 3 seconds. Well, what we're going to do is we're going to look at that first 3 seconds, and we're going to get that area between our velocity curve and the x-axis. So we have a triangle with a height of 2 and a base of 3, and remember, area of a triangle is 1/2 base times height. So this would be 3 units. Now it's below the x-axis, so it's like walking 3 steps backwards. But when we're asking about the total distance, then we still went 3 feet. We just went 3 feet backwards. So our total distance traveled is 3 feet. Now, let's look at the next question. What is the total change in position or the displacement of the object during the 10-second interval? Now, displacement only cares about how you change relative to your initial starting point. So one thing we might do is we might break this up into a few shapes. So here we have a rectangle. It's got a base of 3 and a height of 2, so this area is 6. We'll call it -6 because we're still moving backwards. Here we got another triangle, base of 2, height of 2, times 1/2 is going to give us an area of 2. We'll call it -2 again. And here's where our 10 seconds end. And once again, we got actually an equally sized triangle of 2. So our change in position is actually going to be the signed sum of these numbers, because now we're just talking about where we are according to our initial position. So we take the -3 plus -6 plus -2 plus 2, and we get -9 feet. So in other words, we're 9 feet behind our starting position. Let's look at a couple other questions. For instance, the total distance traveled. Well, now we do care. Now we do count whether we're going backwards or forwards as part of our distance. So we're just going to take the absolute value of each of those numbers. So 3 plus 6 plus 2 plus 2. Our total distance traveled, according to our graph here, is a total of 13 feet. Now, last thing we want to do is we want to set up our 3 situations in integral notation. So let's see how those would look for each situation. So situation 1, we were looking for the total distance, and one way we might write that is the integral from 0 to 3 of the absolute value of v of t dt, because we had to take the absolute value of it when we found its area. The next one, when we found the total displacement, that's what our regular definite integral does. So we would just do a definite integral from 0 to 10 of v of t dt. Now the third one, because we had to make any part that was underneath positive, there's a couple different ways we could write this up. One is we could do the integral from 0 to 8 of v of t dt, and because we know that's below the x-axis, let me refer back to my graph so you guys can see it. Because we know it's below the x-axis, we need to make that positive. We do so by putting a negative sign out front. Now, from 2 to 10, it was already above the x-axis. We don't need to change anything. So we could do 2 to 10, excuse me, not 2 to 10, 8 to 10 of v of t dt. If we wanted to write that in a single integral, we could actually do the integral from 0 to 10 of the absolute value of v of t dt. Either way would be fine for writing this up as a definite integral.